Hello everyone, this is a very quick video, I hope so, about applying classification using Weka, and you can run, as I said, based on your memory space, how much RAM you have on your computer, automatically from Windows. You just go to the to your start and you just write Weka. Weka, and you run it from here, or I prefer always to run it from the command line. So let me show you. Did it before, and so I just go to the directory where is Weka is. Files, and then I go to Weka, and from here I run Java, and then dash x1024 megabyte, and just write that I want to run the jar file, and after that I will call weka.jar. But if it's working fine from Windows for you, go ahead and use it. So I made a mistake here, it looks to me x10. Didn't recognize the capital M. Okay, so now you open the Explorer, and I will maximize it now. So we're going to use one of the data set that already exists in our Weka folder. So I'm going to open the file, and as you remember, it's in program files, and since I'm using this bamboo, it's a little bit more difficult to find. Okay, data. Okay, I'm gonna use we have different data set, but for the purpose of the classification I would like to use a data set that has a training data set and a testing data set, so you can grasp the concept and see the variation of how you can test your learning model, the classifier on a testing data set. So as you can see here, we have a segment challenge data set that it has a class, and we're gonna see the data, and we have another one which is only for testing. So let us open the segment. And as I said, always, if I provide you with a data set, you have always to remember that to go and to look at the data. So let me open the edit and have a better look at my data to understand what type of data I really have. And if really I have some data that need discretization, so I have to pay attention to that. Okay, so this data, as I can see, is numerical data. All the attributes are numerical, and I have the class as a nominal, and it's like a type of distinguishing based on the attributes what kind of class I have. Is it a picture of past, maybe grass, maybe it's a window, maybe it's sky, and maybe it's a brick face, maybe it's a cement. We can know how many classes attributes we have by just clicking on the class, and from here you can see we have 7 values, different values for the class. Okay, and technically we have about 19 attributes in our data, as you can see here. If you look at each one of them, since it's numerical, it gives you the statistical analysis about it, like the minimum value, the maximum, the mean, and standard deviation. You can visualize your data. If I ask you screen capture the visualization of your data, you will be able to do something similar to that one. Copy and paste this one to your report in your test, and maybe talk a little bit about your data. Now, since my data really, I don't have any problem with continuous attribute, I don't really need to do any kind of filtering. I will go ahead immediately to my classifier, which is the second tab. Okay, We talked a little bit in the almost at the end of our chapter 4 in the video about this kind of, if you remember, a little bit about cross-validation, if you remember, the folds, when I said that you can have 20 folds and you can vary those percentage split between your data. You can use only the data that we saw now here, and you can say, okay, I want a percentage, so use 2/3 of this data as a testing, as a training data set, and provide me with best classifier. So let us start with very simple. So let us say, okay, I only want to use a training set to create a model. So I click choose, and from here you have plenty of classifiers. We're gonna look at the tree, and we saw those are similar, so maybe we use a G48 or decision table, which is based on the rule, which, as I said before, it's very simple, similar to the decision tree, just the number decision table. So if you pick that one, and actually if you double click here on the model, you can change the attribute. For example, the cross value is 1. You can make a lot of changes to the evaluation metric here. That as you can see, the accuracy is used. You may change it to a different type of validation. Sorry for that. And you can pick some other that if you are familiar with, maybe discrete class only. So you can pick any attribute you want. And that's it for the time being, and we're gonna run. Okay, so you can make a lot of changes in the dialog. I will leave it as it is, and so as I said here, we are only gonna use the same training set just to create a model here. We are not predicting a new model. Usually go to start, and you can see the bird. If you have a big data, this bird will keep turning his face left right until the whole process go through. So what we can see here, you can look at the data, how much is true positive, false positive, the precision, the recall, the if measurement, and the rock function, which is really good here, as you can see, almost 1. And for that specific attribute here, it's 1 actually. So the overall, so this is the average overall, it's the values are really high considered, and the false positive is very low. It's very promising results. The confusion matrix, as you remember how much of those attributes were distributed. It would be great if only were distributed in this in diagonal. Here, for example, for the window, it's the worst distribution, as we can see, because we have 170 in the we can say in class E, but we have 2 that were in class D, 21 in C, and 11 in A. So that's caused this small non-accuracy in the predictive model. However, the other were less, like this one, only those two outliers outside the class. And this one, we had the biggest one in C. However, we have 4 here, 18. However, the model is good enough, and we can say that it worked fine. We used one algorithm, which is the rule decision algorithm. And if I look at the model, let us try another classifier from the tree, and this is like the decision tree that we use. It's one type of decision tree. As you can see, the model is much better, and we have higher values here. Also, you can see from the classifier. So here, as I said in my theoretical video, based on the data, some classifiers work better on different data sets. We can look at the decision tree, at the visual tree and the splitting, and this is a really good example to look at the data. Now, if you right click here, maybe you will say fit to screen, so you can be able to see it. You can see some kind of like, okay, so it started with the first attribute, the region centroid row, and if it's bigger than 155, then it went to the other one. If it's less or equal, went to the second one. So this is what we said in the our theoretical aspect. Now, if you want the auto scale that will fit the whole, so you can see all the area, but now you have to scale and you have to move around to be able to see the whole data and how it works. So it's really more difficult to manage and to go into the data. You may center on top. So you start from the top and you move around. Usually, if the data is having a lot of attribute, I will go to the fit to the screen and I will try to look at the data, and those are the leaves. So you can distinguish the leaves that they are like squares, and you can distinguish the attributes that they are like oval. So it as close. So if I ask you, okay, give me a screenshot of your decision tree, you just copy this one and you. Let me see if you can save this one. Okay, we have actually the size, we can minimize it so then we can see it better. It's so small actually. A little better. You can print a screen and just add it to your report if I want something from you in this way. Now this is only we use a training set, we didn't use a testing set. Now we can supply a testing set if we have a testing set. In this case, that's why I picked this data, because we have a testing set that we can use, and that one is a segment test. Okay, and in this case, don't change the class because we want to use a class as our destination. And we're gonna start with it and we'll see how accurate it is. And we saw so it applied on, it predicted our model, and we had the results. So actually what we did here, we used the testing set to see how accurate is our model, and to know if the model is really accurate and it worked well on our data. And you can save the model afterward. So from here, let's right click, and what you can do also, you can define the visual cost curve for each one of those attributes. It's also important. Also you can save the model. Okay, and so you have the model saved as it is. So let's say new model, and I can put it in the same data set. Let me see what kind of information I have here, so I'll leave it as it is. So you can, it didn't allow me to save that to the place, so I will save it in different place because I'm running the data. So let's say in desktop, and I will create Weka here, and I will just save it here. It allow, because the folder is open the data, so it didn't allow me to save in the same place. It's running Weka for me, and I can use that model for other type of data that's similar to this data. The cross validation, as we said, the fold, the k-fold, if you remember, you can apply this one and see which one is bringing you a better result. So it's working, and now let us compare between the two results. As you can see, it worked a lot until it came up with this one, and here we can see that can distinguish with the previous result, and I can see it's very good result here. Only with the window again we have some problem, so you can remember one of those numbers and accordingly. So let's say the true positive or the log function 0.985. So accordingly, let's say with a percentage, how is it better or not? It was less in this case, 978 to 985. So based on what kind, maybe of attribute based on which type of division you picked, the result will be different. Also, it's not only one classifier. You can use different kind of classifiers. You may use, let us see if we, Bayesian, we have Bayesian. Also, we have the functions. This is very popular, the SMO. The random also is popular. The voting also sometimes works very good with data that it required voting. This is more the rules. We saw it at the beginning. So let me try another, the random forest, and keep in mind the better one was, the function was 985. We get very high value, very good, very good result actually, very good result, almost one. So as I said, it's based on the functions that you are using, it's based on the algorithms that you are using. So this is what typically that I'm gonna ask you. Try many different classifiers, and based on the classifier that you find the best data, you have to copy this information for me, and I think that you can also get the information, save them. Okay, you can save the result buffer, and you can put them in your report. Let me see the curve based on the windows. It's the one that's causing some kind of problems, and as you can see, the post, it is a 1 and the 1. So actually you can give the data, each specific data, what it caused, and the one that it causing the problems mostly. You can get the information for each specific point in your data set. Seems it is behind the scene. Yes, so I was moving it, but it was behind, so it was bringing the data. So double click on the point that it has value, and you can evaluate each point and see how much expected cost and the threshold that was applied, and the probability cost of that specific instance that you are looking at. We didn't talk a lot about those, so don't worry about them, but I'm giving you some extension that to Weka that you can use. So I'm doing right click on the so let's say the classifier error, how much errors we have. So those are the errors that we saw in our data, because we saw a very small errors. So this is one of them, this instance, and we can look at the data and see if it's really those errors. And remember what we did previously with the visualization, and it could help us a little bit to see if really our classifier is working fine. So we can predict, and since we have based on, so we have 7 different attributes, different category in our class, and so as you can see, based on each one of them, based on the color, you can see, for example, the red is here, the sky is completely classified. The window, the one that it caused a problem, which is pinkish a little bit, it's the one that is mixed with other data somehow. Okay, so you can get a better picture of your data. Let's see another type of okay, so you can save the model, reload the model, You see the cost benefit analysis for each one of those, and visualize the margin curve. And this is a margin curve, and you can look at each one separately as an instances. So technically you have to concentrate mainly on the values the average weighted values, mainly to say if zero classifier is working fine, and the other one if you have a pure classification, that means in one set you have all your elements. Like in this case, for example, the sky 81 is in B, I have 0 on all the other classes. This is pure, completely pure. Also the class is completely pure. So I hope this video, about 20 minutes, you had some kind of understanding of classification. I will encourage you to go and to look at the different data sets and to apply them. Please, if you have any questions or any things that you didn't understand from my videos, I would be more than happy to answer those. If you, it's not, it's completely better to ask now before the test than wait after the test and ask questions. So please send me any concern, any questions. If you still have problems with running Weka, I know most of your friends that they had problems, their Weka is running, but if you're still having some cases, you are still having some problems, just let me know. I will be more than happy to help you even access your computer to see if I can help you in running Weka. So that's for now, and I think we covered the unit completely, and then we'll move to chapter 5, which is continuous to this chapter, also on the topic of classification.